video, I'll give you some tips for solving the ALEKS problem called drawing the unit cell of a 2D lattice. So this problem is going to give us a lattice. The lattice is going to contain two atoms. I've got pink atoms and purple atoms, and it's just going to ask us to use this little highlighter over here to highlight the unit cell of the lattice. The unit cell is the smallest repeating pattern that we can see in the lattice. Now, we're all going to be looking at a slightly different lattice. I'm not going to show you a ton of examples of this problem, but I am going to give you enough information that you'll be able to find your unit cell no matter what your lattice looks like. So what you're going to be doing is looking for repeating patterns. And you want to be looking for repeating patterns in 4 different ways. You want to be looking horizontally, looking for a repeating pattern as you go horizontally for the pink atoms, and also looking horizontally at the purple atoms. And then you want to do the same thing vertically. You want to look for a repeating pattern vertically for your pink atoms, and you also want to look for the repeating pattern vertically for your purple atoms. So I can see here with my pink atoms, they're not the troublemakers. The pink atoms are everywhere. The repeating pattern, if I was just thinking about the pink atoms, not taking the purple atoms into consideration, my unit cell would be something like this. I would just be highlighting a box that just contained or just connected any 4 of those pink atoms. So again, if I was only looking at the pink atoms, if I didn't have purple atoms, any one of these boxes that I'm drawing would be the correct answer to this problem. Those are all identifying the smallest repeating pattern for those pink atoms. Now, if I have to take the purple atoms into consideration, I got to think a little bit more carefully because the purple atoms are a little bit more spread out, they're sporadic. So not only do I need to include the purple atoms in my unit cell, I also need to reflect the fact that the purple atoms are not present everywhere. So there's a purple atom here, and then there's some gap before we see another purple atom again, and that needs to be included in the way that I reflect my unit cell. So maybe I'm going to reflect the unit cell by saying it looks something like this. I've got the purple atom, and then I need to show that there's a gap before I come up with another purple atom again. And you can see that I could actually draw that same shape again. I could replicate that shape, and I could actually replicate that shape through this whole entire lattice. And that's what you're looking for in this problem. You're looking for a way that you can draw a square or a rectangle or something where you can just continue to kind of tile it up through this whole entire lattice, and you're going to see the same atoms inside every single one of these unit cells. So some of these do get a little bit tricky, like what if I'm going to add that is supposed to be the same color purple. That is really not the same color purple. I'm going to try to make it a little bit closer. So this is supposed to be the same color purple as what ALEKS already has in the problem. So what if this became my unit cell? What if it looked like this? Now this is getting like really complicated. I could put some up here too. Okay, so what if this is my unit cell? What I see then is I have, I better put some over here. Okay, so I have purple and then a gap, purple, 2 purple and then a gap, 2 purple and then a gap. If that was my unit cell, I would need to make sure that I was including 2 purples and the gap in my unit cell to show that. Now you might be saying, well, why couldn't it be drawn this way? Like, why couldn't it be that? It can. That can absolutely be a unit cell because I can repeat that tiled pattern the whole way through. That's no problem. Also, you might be saying, wait, I thought it was going to be this. Why could it not be that? It totally can be that. There are going to be multiple correct answers for most of these different lattices that you're looking at. So again, just like, it's kind of like a puzzle. Look for your repeating pattern. Recognize that there are going to be multiple correct answers. ALEKS is programmed to accept multiple correct answers to this problem. Good luck.